In this video, we are going to be talking about the oxidation of alcohols. So first thing to note is that oxidation is the reverse of reduction. We saw that we can take carbonyls and we can reduce them into alcohols, but now we are going to take an alcohol and oxidize it back to a carbonyl. So, in general, when you are oxidizing alcohols, the outcome of the oxidation is going to depend on the starting alcohol. So we have a primary alcohol right here. So if we oxidize it once, we form an aldehyde. If we oxidize the aldehyde, we get a carboxylic acid. So when you are oxidizing a primary alcohol, you can either stop at the aldehyde or you can keep oxidizing it into a carboxylic acid. And we are going to see a reagent that takes it from the alcohol all the way to a carboxylic acid, but then we're going to see an oxidizing reagent that will just take it to the aldehyde right here. So then for secondary alcohols, there's really only one thing you can turn it into. Secondary alcohols, when they are oxidized, turned into ketones. And then tertiary alcohols, just because of the reaction that happens, you need a proton at the alpha position right here, and in this case, there are none. So tertiary alcohols cannot be oxidized. So here is the first reagent, and this reagent is called chromic acid. Chromic acid actually cannot be stored as chromic acid, so it is made in situ, and what in situ means is that it is actually formed while you are performing the reaction. So if I were in a lab and I was using chromic acid, I wouldn't pull out a bottle that says chromic acid. I would actually be using two things called sodium dichromate and sulfuric acid, and while the reaction is happening, it actually forms chromic acid. So, with that being said, we have a secondary alcohol right here, and we said if we oxidize a secondary alcohol, we are going to form a ketone. So chromic acid, all it does is it oxidizes alcohols. But some characteristics of it, chromic acid is very strong. So remember when we talked about primary alcohols, you can either oxidize it once to form an aldehyde, or you can go all the way and form a carboxylic acid. In the case of chromic acid, though, it is not going to stop at that aldehyde. Because it is so strong, it is going to oxidize a primary alcohol all the way to a carboxylic acid with no stopping. So, remember that chromic acid, when you're writing the reagent, is going to be made of sodium dichromate and sulfuric acid, and it will oxidize primary alcohols all the way to a carboxylic acid. Because secondary alcohols only have one product, it doesn't matter what oxidant you use, a secondary alcohol is always going to oxidize to a ketone. Alright, so now we are going to be talking about a little bit more of a mild oxidizing agent than chromic acid. So for primary alcohols, remember it has two ways that it can oxidize. It can oxidize once into an aldehyde, and then it can oxidize again into a carboxylic acid. We said that chromic acid is going to take it all the way to a carboxylic acid, but if we use PCC, we can stop the oxidation process at the aldehyde because it is more mild. So we have PCC over DCM or dichloromethane, and that is just a solvent, and that allows a primary alcohol to stop oxidizing at an aldehyde. For secondary alcohols, like we said earlier, there's only one oxidation product for that, and it's a ketone, so whatever oxidizing agent you use, whether it's chromic acid or PCC, it will produce a ketone. So here are some other oxidizing reagents. We have some strong oxidizing reagents which are comparable to chromic acid. You can use potassium permanganate or nitric acid. And then a couple of mild oxidizing agents which are comparable to PCC are going to be Swern or Moffatt. I hope you found this video to be really helpful. The concepts and information presented in these videos will be true no matter what Organic Chemistry 1 class you are taking. However, the concepts presented in this video are referencing material currently covered in Baylor University's coursework. Remember, if you are a currently enrolled Baylor student, we offer free tutoring services. Our tutoring center is located on the first floor of the Sid Richardson building. You will find all the details you need about these services on our website, www.baylor.edu/tutoring. You may schedule a free 30-minute one-on-one tutoring session online or just drop in during any of our open business hours. For more information about our current services, please visit our website. Thank you.